Okay, so let's take a look at another question from the 2023 HSC Advanced Maths paper. So here we have question 29. So this is a pretty straightforward question if you understand how to do each part. It gets more complicated if you don't really know what to do, especially if you don't know what to do at the beginning. Right? So this question is very complicated if you're not sure what to do at the start. You're probably just not going to get it at all. It's pretty simple if you know what to do. So we've been told a continuous random variable x has a probability density function given by that piecewise defined pair of functions. Find the mode of x. Okay, so the mode is most common. Right? Most common. In terms of the probability density function, what the most common is it's the maximum. Right? If you've got some probability density function that looks like this is the mode. This is the highest point in the function. So this is what we are trying to find. The way we can do this is essentially treat this as a function, find the derivative, set that equal to 0, find the max. So we have f of x equals, we'll expand that function, 12x squared minus 12x cubed. This means the derivative f prime of x is going to be 24x minus 36x squared. If we factorize, we get an x. This is 24 minus 36x. This either means that x is equal to 0, or this means that x is equal to 24 on 36, which is 2/3. Now, one of these is we don't really know which one is a max, which one is a min, or if they're both maxes or if they're both mins. If we look at x as 0, if we plug x as 0 in, the whole function goes to 0. So this, pretty much from inspection, is going to be a min. 2/3, you plug this in, test some points around it, this is going to be the max. Right? So therefore, the mode of x is 2/3. So therefore, mode is 2/3. And this is the answer to part A. Now, for part B, we're told to find the cumulative distribution function for the given probability density function. Well, cumulative distribution function is the sum of all things up to that point. As it turns out, that is just the integral from 0 to t, right, where t is the parameter we're using. The question uses x here, so we will say the integral from 0 to x of this function, that's going to be the cumulative distribution function. So integral from 0 to x of 12 x squared minus 12x cubed dx. So if we evaluate this, this will give us 12x squared. This is going to become 12x cubed on 3. So this will be 4x cubed. And then we've got 12x cubed. That's going to become 12x to the 4 on 4. So that's going to become minus 3x to the 4. Evaluated at the lower bound 0, upper bound x. So if we evaluate this at 0, it's just nothing. If we evaluate this at x, it's just 4x cubed minus 3x to the 4. So therefore our cumulative distribution function, which we might call c of x, is going to be equal to 4x cubed minus 3x to the 4. And this is the answer that we're after for part B. So common theme of both of these parts so far, they're a bit complicated looking in terms of the wording. If you know specifically what the wording means, they're very straightforward, right? So this is a very easy 2 marks each. It's very easy 4 marks so far if you know what to do. It's difficult if you don't. Now, the third part, part C is rather oddly constructed. It says, without calculating the median, show that the mode is greater than the median. So what we can do is we can remember that the mode occurred when x is equal to 2/3. Right? We calculated this in part 1. And then the cumulative distribution function we've just calculated in part B. if we plug the mode into the cumulative distribution function, that will tell us what percentage of the scores or what the probability density is up to the point 2/3. If that is greater than 0.5, then it means that the mode is greater than the median, right? Because it has to be the case. If you plug the x is 2/3 in and it gives you, let's say, 0.7, that means a lower number would be required in order to get 0.5. Well, the number required to get 0.5 is the median, right? So if we plug in 2/3 and we get a cumulative density value greater than 0.5, that means that the mode must be greater than the median, right? We can infer that straight away. So we are going to plug into C of x, the cumulative function we just found. So we get C of 2/3 is 4 times 2/3 cubed minus 3 times 2/3 to the power of 4. Now I can put this straight into my calculator. You've got to be very careful when you're putting something like this into a calculator, because it's not necessarily going to go nicely. So we've got 4 times 8 on 27 minus 3 times 16 on 81 when all simplified, and this ends up being about 0.59. Now 0.59 is greater than 0.5, and therefore the mode must be greater than the median. And this is the answer that we're after. Notice this is a very classic HSC paper maneuver where the first two parts of a question are used in another part of the question, right? If you've got a question that has multiple parts and one part has got you to do something very specific, probably you're going to be using that somewhere else. So let's talk about the marking. So in the first part, if you find a derivative or some equivalent merit, you will get 1 mark for part A. The second mark, you'll have to get the mode. For part B, if you are able to somehow identify that a cumulative density is going to be an integral, this will get you 1 mark. To get the second mark, you have to have the correct cumulative density. And then for part C, if you are able to somehow substitute values used in the first parts, this will get you 1 mark. If you do it incorrectly, just the 1 mark. To get 2 marks, you'll need to provide a correct solution. So get the value 0.59, then infer what you need to infer from that about the mode and the median. So this is how we do question 29.